My most recent database that I developed is for SowCo Develops proprietary homeschool management application, or I will simply show you my code here and give you a high-level overview of my database design and highlight some areas. If you are experienced in database design, you can see the actual product that I develop so that you know what you may expect from me. Or if you are a not so technical manager, you can have an idea of how I work principally to see if we may be a good fit to work together. The script that I am scrolling is for the OR database. It is a PostgreSQL database. I originally developed it in 2017 as a MySQL database for which I used InMotion hosting to manage it. At that time, the homeschool records application was developed in PHP, so a MySQL database was ideal. Then in 2020, SowCo Develops made the decision to migrate the PHP application to Ruby on Rails and to move to DigitalOcean. With that, we determined that in addition to the application move, we would also move the MySQL database to PostgreSQL. There are 47 tables in this database. As we are doing a quick scroll through the code, you can see that there is over 3,500 lines of code, including whitespace. Included in the script is the import of the data from the MySQL tables into the new PostgreSQL tables by using the copy command. These files imported are CSV files, otherwise known as comma delimited files. Then I also have drop table statements for the entire database. I use these if we are recreating the entire database. One thing that I do realize is that I may use system tables to automate the drop tables of each of these. However, I do prefer to write each one out to keep it fresh in my mind and to ensure that I am keeping everything up to date in my processes every step of the way. Then, because we were moving to Rails, we had to do additional work to create the models based on the existing database. So that is what this next section does. Then finally, we have custom updates that I logged in the script that were done shortly after our import was complete and really as part of the import, but it was not handled in the initial setup. Mainly this section has to do with permission grants for users and adding any additional data that was added during the migrational period from MySQL to PostgreSQL, so those data were not in the MySQL database at the time of export from that platform, and it had to be added. Now, heading back to the beginning of the script, you see that I have the script header and documentation. Documentation is very important, and I use comments and scripts as informal documentation in addition to the formal documentation and technical writing and manuals that I develop. I utilize the script header and documentation section to give an overview of the script and document pertinent information as well as items in queue for that script in particular. Then I get into the detail specific for the product. At the beginning, the first tables created are those that are applicable application-wide, such as reference, plan, and user data tables. In this section, I created a custom authentication module that allows for a variety of user scenarios, such as a single user having only a single account, a single user having multiple accounts, multiple users associated with one organization accessing the organization account, and the like. I did a significant amount of research and put a good amount of thought into this authentication module, and I have tried to take into account every use case I could imagine when it comes to user access. So the authentication model here is robust. Special thanks to a blog article from Dun that helped me to solidify this data model for authentication. I linked Dun's article that I referenced in the comments below. Then there are the tables having data distinct to the account. We start with the reference data tables that are specific to the accounts. Things having to do with grades, school years, people and organization data related to the school, school material data, school activity or class data, data specific to the students and scheduling, syllabus data, and finally, the log of all the student school tasks and all related task data, plus a table for notes related to the school in general. A few items to note in regard to my development is first, I have 6 standard fields in every table. All tables come standard with in queue, status ID, updated by, updated at, created by, and created at for record keeping purposes. Historically, I have used the status ID primarily to note if the record is active or inactive. Then the created fields indicate when and by whom the record was created, and the updated fields log when and by whom the record has been updated. These fields are invaluable in investigating questions about or any issues with the data. Then the most recent default field that we have included is in queue. As use cases progress, the database inevitably progresses as well, and so much of the time a new field is required. The issue, however, is that oftentimes while the data is immediately required for production use, it is often the case that updating the database and related procedures that access the data is not so easily done in a timely manner. It is in these circumstances that we use in queue. We store a JSON string in this field that shows the database fields and data that we need when time allows for implementation. At the same time, it provides a solution for immediate access to data that may be utilized up until the permanent field and procedures are put in place. By using this field, we address both critical needs to get what we need when we need it and keeping plans in place for our database to be in order for the greatest efficiency long term. A second item of note are our constraints. Indexing and constraints are paramount to data processing and efficiency and timeliness when dealing with large data sets. So we pay extra close attention to these and make sure that every field or group of fields that are referenced often have constraints assigned to them. Then a final item to note, with many of the tables, we utilize the on-delete cascade command for foreign key constraints. We keep a keen eye on clean databases and good housekeeping, and part of that is ensuring that we do not have orphan data in the database. For example, for this homeschool records application, when a user deletes their account, we do not want the account data deleted and then have all of the school data related to that account remain in the database. The on-delete cascade ensures that we are keeping the database clean and maintaining its good data integrity by destroying all related child data when the parent's account data is destroyed. If it helps to see the database at a high level visually, here it is. I have fragmented it into different pages in this diagram just because seeing it all on one page may be slightly overwhelming the senses. We first have the application-wide reference tables, followed by the authentication tables, then school reference data specific to the accounts, people and organization data related to the school material data, school activity or class data, data specific to the students and scheduling, syllabus data, and finally, the log of all the student school tasks and all related task data, plus a table for notes related to the school in general. So I have used this OR database as an example of my database development so that hopefully you have a general picture of how I work and the product that you may expect from me if you hire me for your database development needs. Thank you for taking the time to listen.